Hello folks, David here from Terrain-Tronics. We're going to talk about terrain today and the trends that we see in it. And one of the ones is adding lights and interactivity to your boards. Now this one has 8 LEDs and a control box that's driving them all with sequences and patterns. And the whole thing is powered from a USB brick that you can see up there, so that you get a long battery life, but also this really cool interactivity. Now, the point of this presentation is to get you familiar with some of the terminology we work with electronics, and to get you familiar with hooking things up, hooking up LEDs and so on in the systems that you're dealing with. Electronics is just like water. If you think of it like water and think of how you've used a gardening hose and so on, it really helps. The current is measured in amps. So you'll hear me talk about amps and milliamps and things like that. And essentially it's the how much flow there is, how much water is passed through the pipe in a certain amount of time. Okay, so in water, particles flowing through the pipe, electric current, same thing. We measure in amps. Now, for your kitchen oven, you might be running 13 amps or something, but for an LED, we typically count 5 or 10 milliamps. Okay, so a milli is 1,000th of an amp. So when you look at your USB power pack and you see something that says something along the lines of 2000 milliamp hours, what it's actually saying is I can push 2000 milliamps for 1 hour. But if you don't consume 2000 milliamps, let's say you consume 1000, you get 2 hours out of it, or 500 milliamps, which is half an amp, for 4 hours out of it. And you can see how that, if we're really power efficient with how we run our LEDs, we can get many hours of performance out of one USB power pack. So that's current. Now, if we talk about resistance, think about resistance as the diameter of the pipe. So when you hear me say, hey, we need to add a resistor of some kind, the higher the resistance, you might think of it as the thinner the pipe is. So let's say you've got a garden hose that's a half-inch hose versus a quarter-inch hose. You're going to be able to get more water through within 1 second. You're going to get more current with a half-inch hose, which is a lower resistance than a quarter-inch hose that has a higher resistance. And so to get the same amount of water through, you've got to increase the pressure, the water pressure, right? And so that's where we get the concept of voltage from. Voltage is the pressure, the amount of pushing that's going on those electrons in the electricity. So yeah, volts, think of it like pressure. So a battery you might think of as like a water pump of some kind. And so, if you think of the amount of push that comes from the pump, USB is 5 volts. Your laptop power supply is probably about 19 volts or so, but your Tesla, your electric car is 350 volts. So obviously that Tesla is storing all that power. You're not going to run your car off 5 volts, right? You're going to need much higher power than that. Now, if you think of this as a circuit, let's start with this water side so far. This is the pump, right? It's pushing water up around through a water wheel here. And you might think of this as your light or as a fan, as this picture shows on the other side. But the water has to return back in, right? Because otherwise this water pump won't have anything to push. And it's the same thing with electricity. So one of the things to remember is you have to close the loop, right? So if you have a battery pack here, if you have a single battery or whatever it is, you're pushing electrons out of the positive through what we call the load, which might be an LED, which might be a fan, which might be a vibration motor or something. But you have to connect the output, the negative, from this to the negative of the battery. Otherwise, the battery runs out of electrons to push. Now, if we convert the language, okay, my pipe is a fixed diameter, but I want more water to flow. If we convert that to electricity, my resistance is fixed, but I want more amps. So how do I do that? Well, in the real world, a plumber would say, well, if you increase the pressure, more water will flow through that fixed diameter pipe. In electrical terms, it means if you increase the voltage, more current will flow. So if you increase that voltage, from 5 to 12 volts, for instance, but you have a fixed resistor, you get more current. Let's now talk about what an LED is. LEDs are a light emitting diode. It's a fancy way of saying it's a small crystal that when you put volts across it, it lights up. So they're hooked up a specific way. You have a pin for the positive and a pin for the negative. One's called the anode, the other one's called the cathode. But as far as you're concerned, you can connect one side to the positive battery side, the other side to the negative. But, and there's some big buts here, okay? Otherwise, you're going to have a lot of little exploded LEDs in your hands. Each LED has a voltage threshold, so you have to drive it with so many volts, right? And different colors have different voltages. So, for instance, red was one of the first LEDs to be invented, and I think they run at about 1.8 volts. So, if you have a single AA battery, it's not going to be enough, right? Whereas if you have a 3 volt coin battery, that's going to be enough. Okay, but if you look at a white LED, they're closer to 3 volts, and there are some cases where your coin battery just isn't going to be a high enough voltage for it to start conducting. Now, once you do hit that voltage, they look like a short circuit. It's unlimited current. You must limit the current, otherwise the LEDs will just take too much current and they'll go poof. You want to be running your LEDs from between 5 and about 20 milliamps. And there's online calculators to work out how big the resistor needs to be and so on. Now, there are some folks that just get a coin cell and they'll hook that up directly to their battery. Sorry, coin cell battery and connect it directly to their LED. That's awesome. But that's because the coin batteries typically have an internal resistance inside. They don't have a physical resistor, but because of the way they're manufactured, they do have some current limiting capabilities built in. That makes them really convenient, for if you're only going to put a single LED on a piece of terrain, it can be pretty useful for that. The electrons need to be able to get home. So you always need to have a complete circuit where, electricity flows from the positive through the load back into the negative. With something like a switch is we stop this connection, right? We could put a switch here at the top and break this connection and electricity can't flow. And when you close the switch, then it keeps on going. But you can also put a switch on the low side as well. As long as you're breaking the connection, you'll stop the battery from draining through the load. Your basic setup here, okay? So if you want, a simple always on until the battery runs out, and this image comes from evilmadscientist.com, you're going to have your battery pack with a red and a negative, red and black wire. Red is typically positive, the black is negative. You're going to hook it up to your LED. The long lead on the LED is the more positive. That's a really nice and easy one. And you can see here they've placed a resistor in line. That resistor is really important to limit the current. Otherwise, you'll get unlimited current from this. It'll be like, your wide open pipe, and you'll drive too much current through the LED and it will go pop. Now, if you add a switch to this, again, the switch breaks the circuit. It stops the electrons flowing through. Water can't return to the pump to be pushed around again. So again, thinking of that water analogy. And again, in this diagram, look, there's our resistor. It's always there. We always have to limit the current. Now, if you want to do cool stuff, you want to add a processor in place of a switch. Right? So by switching on and off really, really quickly, hundreds of thousands of times a second, we can pulse the LED on and off, changing its brightness. So if you're on only 10% of the time, if you're switching 1,000 times a second and you only switch it on for 100 out of that 1,000, then it's going to look a lot more dim than when it's just on fully. And so by controlling these pulses and using patterns and so on, we can start to do sequences and patterns. So things like breathing LEDs, flickering fireplace effects. And once you do that with multiple LEDs, you can start doing sequences like that runway that we saw at the beginning of this video. So let's have a look at what the sequence looks like in code, right? This is my airstrip that I made, and this looks pretty complex. But when we break it down, if we look in the code that I wrote, it's actually pretty simple. So each step in our sequence is one line. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 steps in this, right? So 1 off, 2, 3, 4, 5, 6, 7, 8, 9. And so each of these ones and zeros represents one of the LEDs. So this first one over here is, I think, this one. The second one is this one, and so on. And you can map that when you actually finish building your terrain. You don't have to decide that up front. The brightness, now in this code, fully on is 0 and fully off is 1023. So in this pattern, right, it's either all on or all off. But if I wanted a flickering or a breathing LED, I would change these values and ramp them up and ramp them down and so on. And then finally, this is the duration in milliseconds. So milliseconds is 1,000th of a second. So 500 thousandths of a second is half a second. So this is half a second on, half a second off, half a second on, half a second off. Then step, 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 step through the pattern. And then finally, we're off for 1 second at the end. Pretty easy stuff. Again, I always say if you can do Excel, then you can do this. This isn't rocket science, I don't think. Okay, so in summary, different color LEDs have different voltage thresholds. So remember, your red ones are like 1.8 volt, white ones might be nearer to 3, and you need to have enough voltage in your power source, whether it's a coin cells or A batteries or even a USB source, to overcome that voltage. Now, LEDs only work in one direction, so when you look at them, the long leg is positive. Once the LED switches on, so once you've got enough voltage, you must limit the current. Otherwise, they just look like a piece of wire that drops a certain voltage. And if you drive too much current through there, you're going to make it blow up. Not badly, it'll fizzle and not work anymore. Switches can be on the positive side or on the negative side, so before the LED or after the LED. Remember that voltage is a measure of the pressure from the pump, if you think of it as water or the battery. Current describes how much flow there is, and resistance measures the resistance to the voltage. Now, LED lighting in your systems can be simple or detailed. This is the simplest system we've seen, and a lot of crafters do this. They just use coin cells and they just, they push them between the pins. And because these coin cells have a high enough resistance built into them, you don't need an extra resistor. But there's no switch, there's no patterns, it's not rechargeable. But if you're just making a simple, small piece of scatter terrain and you just want one light on it, it's actually a nice solution. And maybe that might be your first piece of terrain with LEDs in it. Now, if you want to do something a little bit more complex, you can use something like the Harlech Castle 8X LED driver. So this can drive 8 LEDs with Wi-Fi control in some cases, or not if you want to keep the code simple. And you can do breathing, flashing, and sequences. Like the light strip that you saw, and so the landing strip that you saw, and so on. So where do you go from here? Well, you can find Terrain-Tronics on Facebook, Instagram, and Twitter. Come and have a chat, right? I always respond. You can check out the boards, the Harlech Castle boards. We sell them in pairs on Tindy. And if you want to learn more, because I understand that electronics is not a simple concept for folks who haven't lived in that domain for 15 years, you can come join our YouTube channel, subscribe, and there's a playlist there that takes you through going from zero to hero with LEDs in your terrain. Thanks again, folks.